Good morning. In today's lab, we are going to conduct an experiment on ASK generation and detection, that is amplitude shift keying. As we know theoretically that amplitude shift keying is nothing but it is a modulation technique in which carrier signal is varied in accordance with the message signal. But since we are in the keying process, that is in the digital communication, will be having the data signal, that is the message signal, in the binary form, that is in zeros and ones form. So we need to give the keying input in the square wave format, which will be multiplied with the carrier signal. So for this we are going to use an IC 4052, which is a multiplexing bar demultiplexing IC, which is in total used for ASK application as of now. So this is a 16 pin IC in which you are having 4 input lines. Actually, first pin, second pin, fourth pin and fifth pin will act as input lines. But as of now in this experiment we'll take only the fifth pin for the input of carrier signal. Here carrier is passed through a capacitor and a diode, that is just for clamping the carrier signal, that is the sinusoidal signal which I am going to pass here. Otherwise the negative part will be clipped off, that is at the pin number 5. Then this is a message signal. Keying input is nothing but a message signal whichever I am passing at pin number 10, and this will be in the form of binary zeros and ones. And at pin number 3 we are going to see the output. Here pin number 6, 7, 8 and 9 are shorted. The reason is very simple, because pin number 9 and 10 will act as select line for this particular IC 4052, because when you have the input signals at pin number 1, 2, 4 and 5, this IC will take it through the select line. So pin number 9 and 10 has 4 combinations when it is acting as select line, from 0, 0, 0, 1, 1, 0, 1, 1. But since this IC is working with pin number 5 and 10, that is multiplying the sine wave and a square wave, it will take only 2 combinations, that is 0, 0 and 0, 1. Ninth pin is always grounded, that is why it will be always 0, and this 10th pin will switch 0, 1, 0, 1 because of this waveform. And demodulation is a process where detection is a process where we are getting back the original message signal. So you connect the ASK output to this particular point. This is a combination of a diode and a capacitor, wherein you can convert the high frequency component to some low frequency the output will be with high frequency. So let us come to the circuitry part. This is a circuit with the IC 4052, and the connections are made, to which I am given a power supply of 5 volt from here, and these are the 2 function generators used to connect the data, used to connect the message signal data, that is a square wave. So you can see here this is a square wave which I have given to pin number 10. So this is the pin number 10 where I have given this is the pin number 10. Next sine wave I have given at pin number 5. So this is a sine wave which I have given at pin number 5. You can see both. Now you have to observe the output at pin number 3. Let me observe the output at pin number 3. So when I connected pin number 3, you can see the waveform, that is we are having a high frequency component and a zero line. So now it is ASK modulated, that is message signal, sorry, the message signal has been multiplied with the carrier signal. This is the message signal, data signal. It has been multiplied with the carrier signal and we got it like this. That is high 1 multiplied by 1, you have got some components, high frequency. 1 multiplied with 0, it is 0. That is what you can see in the CRO. Next is yes, clearly you can observe that if I keep a carrier and output signal, you can see wherever the carrier is high, not the carrier, you can see the message signal and the output. Wherever the message signal is high, there only you can see the high frequency component. That is what the meaning of carrier and message signal multiplication. Wherever your carrier is, wherever your message signal is high, in that place only you can see the output when it is multiplied with a carrier. So that is one observation. Next, we'll go for the demodulation process. In the demodulation process, you need to connect this ASK output to the input. So this is a circuitry part where demodulation circuit is done. This is a diode, this is a diode, this is a resistor, and this is a decayed capacitance box which I am going to use. I have to observe the output here at this point, that is across the resistor and ground. So when you see here, we should get the message signal, that is we should get the exact keying data, but you can see some variations, that is due to the carrier frequency. So slightly when I increase the carrier frequency, we get almost demodulation is done, but there is a slight variation in the demodulated output due to some change in the capacitance. So yes, so now it is almost equal. So this is what the ASK generation and detection process.